Okay, you guys, so today we're going to work through homework set problem 1 and 2 if you want to take a screenshot. Okay, so for the first problem, P represents pressure, Z represents distance, this represents density, and this is gravity. So there's a couple things I want you guys to notice when looking at this equation. D represents a very small value, and then also the reason why we have this negative sign is gravity. So for example, I'll draw a piston, and this is a terrible looking piston, I'm sorry. But anyhow, so what we define is downwards. Gravity's going to act downwards, and so we define that as negative, and if gravity acted upwards, it'd be positive. Okay, so for question 2, we're going to apply this equation to calculate the air pressure at varying altitudes, assuming a constant temperature. So the first thing I want you guys to notice is this value. So we also know that density equals mass over volume, and we also know from the ideal gas equation that PV equals nRT. So we're going to solve for V, so we get V equals nRT over P, and we're going to plug this back into this equation, so we get MP over nRT. And what I want you guys to notice from here is that this is mass and this is moles, so this is going to be molar mass, so I'm going to represent this by a big M, so we get MP over RT. Okay, so we're going to plug this back into this equation, so we get dP over dZ equals negative MP over RTG. Okay, now the next thing I want you guys to notice is that we want to get the pressure to the same side of the equation, so we're going to divide by pressure on both sides, and we're also going to want to move this dz over to this side. Okay, so now we're going to do that, so we'll end up getting 1 over P, we're going to move this up for you guys, dP equals negative mpg over RT dz. Okay, so now we're going to integrate, and so we're going to integrate both sides of the equation. This side we're going to integrate with respect to dP, so we're going to do P2 up to P1, and this side we're going to integrate with respect to Z2 and Z1. Okay, so what I want you guys to notice now is that when we do this, we get natural log of P2 over P1, and then we're going to get equals, and notice this is a constant, so we can just pull this out, so we'll get mpg over RT, and then we're just going to integrate with respect to dz, which that'll be z2 minus z1. Okay guys, we're almost done. So now we're going to take the exponent of each side, so when we do that, this cancels out, and then this is raised to the exponent, and now all we want to do is we want to get P2 by itself, so we multiply by P1. So when we do that, we get P2 equals P1 e to the mpg over RT z2 minus z1, and that's all raised to the exponent. And here's your answer. So now you can plug this into Python and get multiple values and arrange for whatever you need. And I hope you guys really enjoyed this, and thanks so much. Okay, you guys, quick update. I was editing the video and I just noticed I forgot the negative sign, so your answers are going to have a negative sign in front of both of those, and make sure you guys are really careful with your signs and don't make a mistake like I did. Thanks.